नमस्कार बच्चों, मेरा नाम धन्या और हम लोग सीख रहे हैं ग्रेड 11 केमिस्ट्री में ऑर्गेनिक केमिस्ट्री का लेसन। और इसमें हम लोग नॉमेनक्लेचर ऑफ अमीन्स एंड ईथर सीखेंगे आज। सो टू स्टार्ट विद नॉमेनक्लेचर ऑफ अमीन्स। सो amines is NH2 and the secondary suffix that we use is amine, and it is not a terminal functional group. That means it can appear anywhere in the chain. Okay, so to start with, naming of amine, nomenclature of the amine. So it's not a terminal functional group, it can appear anywhere. So starting with the simplest one, CH3 NH2. So CH3 NH2, so this has only one carbon atom, so we don't number the amine because it doesn't have the carbon. So this is methane amine. And I removed this E because in my previous video itself, I have told you when E, A, E, I, O, U, Y, when these vowels come near to each other, we remove the previous one. Like E and A are coming near each other, so I remove the previous one, which is E. So I remove E, A. So I remove E, sorry. So it is methane amine. Coming to the second one, CH3, CH2, NH2. So here the carbon atom that is nearest to the functional group is given number 1 position. This is number 2. So there are 2 carbon atoms, no double bonds. So ethane amine. Here also I remove this E because E and A coming near each other. So I remove the previous one, that is E. Okay. Now coming to the third question. Suppose if I give a question like this, CH3, CH, NH2, CH2, CH3. So here, I told you before that it is not a terminal functional group. It can appear NH2, and the NH2 is not a terminal functional group. It can appear anywhere in the chain. So starting to number the chain, this carbon atom is given number 1 because it is near the functional group. 2, 3, 4. I cannot number from this side because here then the functional group NH2 will get the 3rd position. So I don't use this numbering. Okay. So all these rules were explained in the previous video. So the name of this is, there are 4 carbon atoms. So it is butane. The second position is butane and butane. There is no double or triple bond, so butane. At the second position, I have amine. So butane to amine. Here also I'm removing this E because E and A cannot come near each other. So butane to amine. Okay. Now, coming to some bond line structures. So if I give a question like this, okay. So this is carbon atom, CH3. This is carbon. This is carbon. And this is NH2. Suppose, so this is carbon. This is carbon, this will be SCH3. Okay, so this is also carbon. So you can see here there's a double bond. So that means this is a functional group and this is a substituent. And this is NH2 is the functional group, right? Now, what is the name of this substituent? So this is the benzene ring, right? So when benzene ring is a substituent, that means benzene is C6H6. This is benzene. When one hydrogen is removed, it becomes C6H5, and that is this substituent. This substituent is the substituent where one hydrogen is removed from the benzene. When one hydrogen is removed, it is called as phenyl. So this substituent is nothing but phenyl. We don't write benzyl, we write phenyl. Okay, so starting with the numbering. So we will number from this side over here because you can see there's a double bond here. So number 1, 2, 3, 4, and 5. So at the 4th position, I have phenyl. Pent. At the 2nd position, I have the double bond. And at the 3rd position, I have amine. Again, removing this. Okay, I hope I'm clear till here. Moving on further, but before moving on, just wanted to explain. This is the phenyl group that we wrote. This is the phenyl group that we had written. Phenyl. Sometimes phenyl group is also represented like this, C6H5, like this also. And sometimes it can also be written as AR. AR means aryl group. Okay, so these are the different ways to represent the phenyl group. So this substituent can be displayed in different ways. It can either be represented as phenyl or C6H5 or aryl. In any way, it can be displayed. I hope I'm clear. Okay. Now, moving on further. Suppose taking another bond line structure. So here, this is CH3. This is carbon. So this is CH2. This is also CH2. And here, the nitrogen is surrounded by 1, 2, and 3 carbon atom. So whenever the nitrogen is surrounded by 3 carbon atom, it is tertiary 3-degree amine or tertiary amine, where the nitrogen is surrounded by 3 carbon atoms. Okay, so numbering. So this is a tertiary amine because it is surrounded by, the nitrogen is surrounded by 3 carbon atoms. So starting the numbering from here, 1, 2, 3, because this, we have to start the numbering from this carbon atom because this is near to the functional group. Okay, so attached to the nitrogen atom, there are 2 methyl groups. So it is the methyl groups are attached directly to the nitrogen. So we write N. How many methyl groups are there? 2. So dimethyl. And there are 3 carbon atoms. So prop, there's a single bond. So propane. At the first position, I have amine. Amine, the nitrogen is connected to the first carbon atom. So one amine, you can either write 1 or you can just write propane amine, and I remove this E. I hope I'm clear here. Now, taking another question or taking another example, if you have a question like this, where there is CH3H. So this is a carbon CH3. This carbon is CH2. Okay. Now here you can see this nitrogen is surrounded by two carbon atoms, 1 and 2. So whenever the nitrogen is surrounded by two carbon atoms, it is a secondary amine. Okay. So we number it from here because this is the nearest carbon connected to nitrogen atom. Then next is, this is the second carbon atom. So connected to the nitrogen atom is the methyl group. So N-methyl, two carbon atom. So they're all single bonds. So ethane. At the first position, I have amine, ethane 1 amine. You may or may not mention one amine. You can just write ethane amine. So I'm removing this E. Okay. I hope I'm clear here. Okay. Okay, students, coming to the next question. If you have a question like this, now here you can see that this NH is this is the functional group. Now here at one side you have a double bond. Here there is a double bond. And this side, if you number it, you will get a long chain. So that means you can number from here 1, 2, 3, like this. Or you can number from here 1, 2. But which one would you prefer? So we are familiar with the rule that whenever there is a functional group, the functional group is preferred over double and triple bond, double or triple bond, and this is preferred over substituent. We are already familiar with the rule, substituent. So definitely we will take the long chain as the substituent. The double bond, we have a double bond, so double bond will be numbered. I hope I'm clear here. Okay. And this carbon is given number 1 because this is closest to the functional group. I hope I'm clear here. Now, so this group, what you see is ethene group, right? Now, this long chain, we do need to check the number of carbon atom. This is 1 carbon atom, this is 2 carbon atom, this is 3 carbon atom. And they are connected, and this carbon atom is connected to the nitrogen atom. So, to the nitrogen atom is connected N-propyl. There are 3 carbon atoms that is connected to the propyl group is connected to the nitrogen atom. So N-propyl, and the one that we have numbered, 2 carbon atom eth. At the first position, I have E1 amine. And I remove this. I hope I am clear. So students, whenever there is a long chain Whenever there is a double bond, we will number the double bond and we will make the long chain as our substituent because of the preference order. Okay, and to the nitrogen atom, the long chain that is connected is the propyl group, because you can see there are 3 carbon atoms, 1, 2, 3. Okay, so N-propyl eth, 1 ene, 1 amine. Okay, I hope I'm clear here. Now, coming to the next question. If you get a question like this, to the nitrogen atom is 1 bromine atom is connected, CH, double bond, CH2. Okay, so instead I can draw this as a bond line structure. CH2. So here there's a carbon atom, so that is nothing but CH. Okay, so here there's a CH3 group. Here there's a CH3 group. This is a carbon. This is a carbon, CH2. This is CH, and this is CH2. Right. So in this case, how to do the numbering? So which part do we number? So here, definitely there is a double bond over here. You can see there's a double bond over here. So definitely this will be our, we will number as 1, 2. Okay. And this will be our substituent, and it is a complex substituent. Similar to the previous one, whenever there's a long chain and whenever there's a double bond, definitely we will follow the order: functional group, then double and triple bond, then the substituent. So this is our order. So because there is a double bond here, so we will take that as our long chain. I hope I am clear. Right. Now this complex substituent, definitely we have to number because it is a complex substituent. So the carbon atom that is connected to the nitrogen, we gave number 1, this is number 2, and this is number 3. So connected to the nitrogen atom, there is 1 bromo group, right? And here there is a C2H5 group, that is ethyl group, right? So here there's a bromo group. At this side, there's an ethyl group, right? So these are all our substituent now. So writing the name now. Connected to the nitrogen atom, we have bromo, because B, it starts with B, so I'm naming according to the, so we have to name according to the, writing the name according to the alphabetical order, N, bromo. N is also connected to the complex substituent, so I put it in the bracket. At the first position, I have ethyl group. You can see this, at the first position, I have the ethyl group. So, first position, I have ethyl. And the complex substituent, how many carbon atoms are there? 1, 2, 3. So propyl. I'm not writing propane because it's a substituent. Ethyl propyl. So we finished naming the complex substituent. Then coming to the long chain, that is the one that has a double bond. So we write, there are 2 carbon atoms. So eth, 1 ene. There's a double bond at the first position. Eth, 1 ene. one amine. You can just write amine because amine is at the first position. Okay, so this is how we name. So students, whenever there is a long chain and whenever there is a double bond, okay, whenever you, this kind of a situation where there's a confusion whether to make the long chain with the double bond or to make the long chain as the so this is the name. Okay, I hope I'm clear. So here we preferred this as our long chain because here there is a double bond and we looked at the preference. I hope I'm clear here. Right. Now, moving on further. Suppose you have a question like this, CH3, CH2, N, CH3, CH, CH3, CH3. So here we already discussed that amine is not a terminal functional group. It can appear anywhere in the it can appear anywhere in the chain. Okay, so here if we have to number it, so this appears to be our longest chain, 1, 2, 3. Okay, so here if we number, we get only 2 carbon atom. Here there is no double or triple bond, so we just take the longest chain. Okay, so we have an ethyl group connected to the nitrogen. We have a methyl group connected to the nitrogen. And we follow the alphabetical order while naming. So N ethyl, N methyl, then the longest chain is having 3 carbon atoms, so prop. There is all single bonds are there, so propane. At the first position I have, at the second position I have amine. The nitrogen is at the second carbon atom. I hope I am clear here. The next topic that we are going to do is the nomenclature of ether, which is represented by R, O, R dash, where R and R dash are the alkyl group, can be the same alkyl group or different alkyl group. Okay. Now, here this naming is simple when for the smaller chain, we use the term alkoxy. Okay, so R dash, or if R is smaller chain, we use the term alkoxy. And for the longer chain, we use alkane. We will explain with an example. So for the smaller chain, we use alkoxy. For the longer chain, we use alkane. So that's the technique we use here. Okay. Suppose we have CH3, O, CH3. Here, both are the same. So here we write methoxy methane. Because both are the same, there's no problem. We just write methoxy methane. Okay. So this is the IUPAC name. And the common name that we use here is, you can see there are 2 methyl groups. So dimethyl ether. So this is the common name. Okay, I hope I'm clear here. So just sometimes they use the common name. So that's why it is important to know some of the common names as well. Okay. Coming to the second example, CH3, CH2, O, CH3. So here, as you can see, there is a longer chain, there's a smaller chain. So whenever there is a smaller chain, we use alkoxy. So for smaller chain, alkoxy. So here, the alkoxy group is the methane. So methoxy, right? So methoxy. And this is the larger chain. In the larger chain, how many carbon atoms are there? 2 carbon atoms. So we use ethane. I hope I'm clear. So for the smaller chain, we use the alkoxy. For the larger chain, we use alkane. Okay. And the common name here is, there's an ethyl group here, there's a methyl group here. So ethyl, methyl, ether. Okay. So I hope I'm clear here. Coming to the next example. C2H5, O, C2H5. So both the alkyl group is the same. So here, ethoxy, ethane, both the alkyl group is the same. And for common name, both are ethyl group, so diethyl ether. And sometimes for ethyl group, sometimes they use the term ET, like this also. So just to familiarize you with the terms. Okay. Coming to the next question. Suppose you have a question CH3, CO, CH3, then CH3 group here, CH. Okay. Now, this is the smaller group. And this is the larger group. So 1, 2, 3. So smaller group, methoxy. So methoxy is at what position? Second position. So 2 methoxy. Then the main chain or the longer chain is prop, all single bond. So propane. So this is the IUPAC name. And the common name here will be what? This is the isopropyl group. We have done the video on this. So this is the isopropyl group. Isopropyl. Apart from the isopropyl, there's also a methyl group. So this is the isopropyl group. This is the methyl group. This is for the common name. So isopropyl, methyl, ether. Okay, so this is how we do the common name. How can we identify the isopropyl? We have done in the previous video on nomenclature. Okay, so you can go through that video. I think it's video number 3 for the nomenclature of complex alkyl groups. So here you can find it. So I hope I'm clear here. Coming to the next question. Suppose you have a question like this, CH3, CH2, CH3, CH4, CH2, CH2, CH3, CH3. Okay. Now you can see that here on either side you have a long chain, 1, 2, 3. Here also 1, 2, 3, 4. So on one side you have a carbon chain with 3 carbon atoms. On one you have a carbon chain with 4 carbon atoms. So over here you have, this is our smaller group, so alkoxy. But in the alkoxy also at the second position I have methyl. There are 3 carbon atoms, so propoxy. Just like we write methoxy, ethoxy, so propoxy. Then coming to the larger chain, here there are 4 carbon atoms, butane. So this is our IUPAC name. Coming to the next question. Here we have, on one side we have a long chain, here we have a double bond, right? So definitely this will be our main chain because this has a double bond. We have discussed earlier itself. So while numbering, this will get the first position and this will get the second position. So here, this is our propoxy. There are 3 carbon atoms here, 3 carbon atoms. So this will be the propane group. So propoxy ethene. Okay, I hope I'm clear here. So this is the propoxy and this is the ethene group. So propoxy ethene, because we are giving preference to this double bond. So this is ethene and this one is our propoxy group. So propoxy ethene. I hope I'm clear here. Coming to the next question. Oh. So there's a double bond over here. Coming to the numbering. Definitely this will get number 1 position, 2, 3, 4, 5. And if we number this part 1, 2, 3, 4, and 5. So here there are 5 carbon atoms. So this 5 carbon atom and the alkoxy group is connected at the 3rd position. So at the 3rd position, I have pentoxy. Then the main chain has, we consider this as our main chain because there's a double bond here. I hope I'm clear here. So at the main chain, I have 5 carbon atom, pent. At the first position, I have a double bond, ene. So this is the name. I hope I'm clear here. Coming to the next question. Now, if you see this question, you have a double bond at one side and you have a triple bond at one side. So whenever there is double and triple bond tie between a double and a triple bond, definitely the priority will be for the double bond. Please remember, this is only for those conditions whenever there is a tie. Okay, otherwise both are of equal preference. Okay, so definitely here triple bond will become the less preferential chain because there's a tie between a double and a triple bond. So ethyne, noxy. Just as we write as methoxy, ethoxy. So because there's a triple bond, so ethyne, oxy. Ethyne, oxy, ethene. Because both are the chain of two carbon atom. Okay. I hope I'm clear here. So here we gave preference to the double bond because there's a tie between a double and triple bond. Whenever there's a tie, then the preference is for the double bond only in case of a tie. I hope I'm clear here. Now, apart from this, there's a small more information. Just wanted to tell you something about epoxy. Epoxy is nothing but whenever you come across a structure like this is called as epoxy. Okay, so for example, if you come across a structure like this, CH3, CH2, C, CH3. So this is 1, 2, 3, 4, 1, 2, 3, 4. Okay. So here, the numbering will start from the nearest end, 1, 2, 3, 4, 5. So 5 carbon atoms, so pent, all single bonds, so pentane. At the second and the third position, I have epoxy. So this whole thing is the epoxy group. This whole thing is the epoxy group. I hope I'm clear. And at what position? Second and third position. So this is how you name it, epoxy group. There's more about it we will learn in grade 12. Okay, so for now, just giving an example. Similarly, CH2, CH3. Okay, so here the numbering starts from here, 1, 2, 3. This is also an epoxy group. You can see 3 carbon atom in total. So prop, all single bonds. So propane. At the first and second position, I have epoxy. So this is how you write the name. Okay, I hope I'm clear. Okay, students, that's all for today. Have a great day.